Today we are going to understand how we will use the gyro sensor to move the robot in a straight line. So of course the first thing you want to do is you want to take the gyro sensor, and every time you take the gyro sensor you guys know that you have to pause it for 0.1 seconds. Now comes the interesting part where you're going to move the robot uh, in a straight line. So put in the loop block. Within the loop block, you first thing you do is you take the gyro and then you put a math block in. You want to change that math block to multiplication. You want to take the input from the gyro. So let's see what we are doing here. You want to take the input from the gyro, put it in A, and then in B you're going to change it to minus 0.5. So whatever reading is coming from the gyro, the math block multiplies it by minus 0.5, and then you're going to take the steering motor block, and you're going to take the output from the math block and put it to the steering here the way I have shown it. Change the speed to your desired level and change it to on number of rotations. Now of course you want to end the loop. So let's say you want to move the robot for 3 rotations, so you will go to motor rotation more than or equal to, and you will change it to 3. Now once of course that criteria is reached, you're going to shut the motors. So this is the whole program as to how to move the robot in a straight line, and I'm going to explain each and every part of this. So this part you understood. You take the gyro and then you pause it for 0.1 seconds. Then you put a loop block. The loop block continues to do a certain action until you reach 3 rotations, and you could change it to several things, but we won't talk about that. You want to move the robot for 3 rotations, and you're going to do okay. As soon as it reaches 3 rotations, it's going to stop. But till it reaches the 3 rotations, this inner working of the program is going to keep the robot moving in a straight line. Now we know that our robot is not perfect. It deviates and it never moves in a straight line unless you correct it. So once you reset the gyro, it's reading 0. As the robot moves forward, let's say the robot moves to the right, let's say 5 degrees. So the gyro starts reading 5 degrees. 5 multiplied by minus 0.5 is minus 2.5. So the input here into the steering will be minus 2.5. So the robot automatically starts moving to the left, and it keeps doing that till it reads 0. Once it starts reading 0, it starts going back to the straight line, because when it's 0 here, this means straight. Now imagine the gyro is drifting and it's reading minus 10. So when it reads minus 10, minus 10 multiplied by minus 0.5 would be positive 5. So the output would be positive 5, and the robot will start deviating to the right. So it will keep correcting itself till the reading here is 0. So again, the reason for keeping minus is because you want to go to the opposite direction to what the gyro is reading. And the reason we chose 0.5, I mean, Param and I experimented a lot with these numbers, and we found that minus 0.5 actually makes the robot, at least for our robot, work the most accurate. So again, use this program wherever as possible, because our robot is not accurate.